This slideshow is about the idea of scale in architecture. Now, the word scale in English has many meanings. It's used in many different ways. It's an old word. Most of these meanings are not relevant to the theory and practice of architecture. And some of them are. More than one directly relate to architecture and what we do with it. So it's important to know um, which ones we are talking about in which situation. So these images show some of the common uses of the word scale. On the top left, you can see a tap, and there is some salt coagulation that has been deposited over time over the edges of the tap. I'm sure you've seen it somewhere. Happens a lot in Ahmedabad, like I said before, because we have a lot of salt content in the water. But that deposit is also called scale in English. Then on the right of it, there is an Egyptian drawing or a painting with hieroglyphs. And in that, there is a weighing scale. And a lot of weighing machines are called scales. Because ultimately, something that is being measured is being scaled. So a lot of things that are to do with measuring are called scales. Same like with the ruler, for example, which is there in the image below that. In India, we do call the ruler a scale, and that is also with the same sort of sense of the word scale, which is to do with measurement. When a person is climbing a mountain, we sometimes do say it is correct in English to say she scaled the mountain. And that's also in the similar sense that when you climb a mountain, when you go all the way up, it is in a sense with your feet or with your climbing motions, you are measuring the height of the mountain, so you scaled it. So that's also another way of understanding the word scale in English. You've come across many surveys and where you have to give stars out of 5 or 10 to Ola drivers or to restaurants and so on and so forth. And this is also a sort of scale. It's a measurement of something's worth or value, or uh, and it's on a scale of 1:5 in this case. For example, you can see the Amazon screenshot for these slippers or whatever they are, and that is a scale of 1 to 5, and then people rate them. So you see an average. So that's a scale. Yet another meaning of the word scale is in music, where you have an upscale and a downscale. So you have the notes going higher and higher and then lower and lower. And these scales are fixed scales, and they are used to practice when people are practicing music. Yet another meaning of the word scale, which is not there in the images, is the scales of a fish. And that is completely different from any sense that we want to use it. The fish has sort of little tiles fixed together on its skin, and these are called scales. So that's all sorts of meanings of the word scale, and that's English is a language which is very funny in that way, and many words have all kinds of strange meanings attached to it. But in architecture, what we mean by scale is basically to do with the idea of size. We use the word scale instead of size. For example, when comparing a building or an object to something that is a known size. For in both these images, for example, the one on the left, we sometimes it won't be incorrect to say that that truck is of an outsize scale, or on the right you can say that bat is out of scale because it's not the correct size. It's not anywhere near the size where it is supposed to be. So this is a sort of similar meaning to what we want to look at in architecture, but still not exactly what we want to see today. But this word does get used a lot, and you will see and hear more of this in your coming years in architecture school. What we are interested in is scale as a method to understand specific sizes of objects as related to the drawings of those objects. So it is a method of notation. So it's a proportional notation to instruct correct construction. We make drawings so that buildings can be made correctly. If drawings were not necessary, then people would just be going to site and saying, this is what I want, this is what I want, number of rooms, this is the height, blah, blah, blah. And somebody would just come and make what you said. But buildings are so complicated that you need way more instruction, and words are not enough. So you sometimes have to, most of the time, these days in modern times, you always make a drawing. And the drawing must be proportional. You cannot be distorted. So there is a way to scale the idea of the building. The building is in reality, which is a full size, but you scale the idea down to something that is into a drawing. So that proportional scaling down of all the parts of the building then makes a drawing which is at a certain scale. So this is so that we understand buildings and spaces according to their proportions, that we need to understand the idea of scale. So now imagine that there was an architect who had to design the pyramids. How was she going to tell the builders how to build these things? And one could say that this would be pretty simple. It's a simpler building than many others. You give the sizes of the sides of the base, and you give the height, and you have a pyramid. That is perhaps true, but there's also a lot of tombs and catacombs and labyrinths inside the pyramid, and how would you actually tell them how to make those? So this could be a diagram, a simple drawing, but then you might need a much more complex drawing to explain further what is inside, right? And so you make a drawing. Now, if the drawing is not in the same proportions as the base to height ratio that we want, then it can get confusing. In this drawing, for example, on the left, it says x and x, and both x are the same number, but the pyramid is taller than it is wider. So that means that there is a confusion between what the text says and what the drawing says. So the proportions are not right. Same with the drawing on the right, the base is wider than the height. So in this case, there needs to be better instruction. These things need to be coordinated. And we know this because many mistakes quite often happen despite of the fact of all our scales and notation conventions. And you can see on the left that somebody saw the elevation of the staircase and just made it exactly in the same plane, so it's impossible to use that staircase. Same with the stadium on the right, where the wall is right in front of the chairs. So it's quite important to understand and to make drawings at the correct scales and the correct proportions so that these mistakes don't happen. And even slight mistakes, even if the mistakes weren't as drastic as the ones just shown, even very small changes can make a very big difference to how a building is experienced. This image shows many versions of the Taj Mahal. But it's quite difficult to say which is the right one unless you've actually been there and studied it for a long time. And you can see that the slight changes actually make the building a very different creature from what it actually feels like. Can you tell which is the right one? What has changed from one image to the next? There are many different things which have changed. Now, if the drawings are a reduction of the actual building, then the reduction must also be exactly proportional. That is, all the dimensions of all the parts of the building must be reduced by the same factor. Now, this we saw in class. The question is, do you think somebody reinterpreted the architect's drawings in this case? Did they make a mistake? Were the plans and elevations crumpled up when they got to the site and this is how the building came out because of that? Or did the architect design this as we see it? If it was designed to be as we see it, then a very complicated building such as this one by Frank Gehry in Dusseldorf in Germany, the drawings must have had to be exactly like this, but reduced and very, very precise. Otherwise, it would be very difficult to make this building with such fine detailing. And especially if your hero is going to shoot a song in front of one of Frank Gehry's buildings, then it has to come out exactly right. So this is a standard drawing of a scaled down version of a building. This is what we call scaling. The actual size of the building is scaled down by a given proportion or factor so that all the parts of the building fit into the sheet that must be given for construction on site. So we said that this drawing is at a certain scale. This is quite important, and you can see that at the bottom of the drawing there is a sort of a title, and in the title you can see that there are only three things. There is the type of drawing, which says plan, there is the landscape plan, which is the name of the drawing, and then there is, it's called the scale, which is 1:100. It's written large and before everything, right underneath the entire drawing, because the scale is quite important. This scale, for example, it is pronounced 1:100. Let's see what this means. So scale is a proportional notation to instruct correct construction. We've just seen that. So these are standard reductions. So there are only certain scales which are commonly used, standard reductions from the actual size to make proportional drawings. Now this is the Dharmaraj Ratha at Mamlapuram. And you can see that on the right is a photograph and on the left is a pretty good drawing of this building. Now if you had to make a drawing of this building at exactly the same size, then you can imagine that you would need a pretty large space and a very large sheet of paper. And you can see that people are walking around all over it so that the drawing is made accurately. As you can see on the right, the size of the people tells us what is the size of the building. But in reality, you would actually have to go and measure the building and then put that down on paper. How would you make the drawing of the Ratha? You would have to measure it part by part. And suppose we take the dimension of the crown piece, which is called the shikhara, the topmost bit that looks a little bit like a helmet. The dimensions of the actual shikhara and that in the drawing must be exactly the same. If the entire drawing has to be the same size. When the drawing is the same size as the building, there is no reduction of scale. That means that 1 unit of measurement on paper represents the same 1 unit on the actual building. When this happens, we say then that this scale is 1:1 or 1:1. Both ways of saying it are correct, but this is the way to write it, 1:1. Now, one small point about this, that this is only a ratio. It's a notation that explains a ratio. It is not particularly to feet or centimeters or any particular unit of measurement. It is a ratio, which means that 1:1 could mean a centimeter to a centimeter, a 1 foot to a 1 foot, a 1 meter to 1 meter, etc. Till now, this only represents a proportion of paper drawing to the actual thing. So this is just 1:1 any unit. So again, we are down back to 1:1 with this building of ours. Now suppose we wanted to make it half the size of the building. In this case, 1 shikhara on paper would be half the size of the actual one. This would mean that 1 unit on paper represents 2 of the same unit on the actual building. This is quite important, so I'll say it again. The unit of measurement on paper represents or shows 2 such units from the actual object. In the drawing, the shikhara is half the size, so it is measured in 1 unit. In the actual, it needs 2 exactly such units to measure it. This is 1:2 scale. Now if we wish to make the building even smaller, reduce 5 times from the original or 20% of the original size, and if we again take the shikhara on the drawing as 1 unit, then the shikhara on the site will be 5 times larger. The shikhara on the paper will be 5 times smaller, reduced, than the actual. This is 1:5 scale. One step further and we are at a drawing at a 10 times reduction. 10 paper shikharas are required to make the actual one. This is 1:10 scale. Now suppose we look at it the other way around. If we have a standard size of paper, we begin to get used to each scale within the paper and what it means a little more. Let us assume that we have an A3 paper at hand. That is, the size is 420 millimeters by 297 millimeters. That's the standard size of an A3 paper. On this, there is drawn a Dharmaraj Ratha, again. Now, to draw it at a certain scale, one must know its dimensions in actuality. So, I know that one of the faces of the Dharmaraj Ratha, the width of it is 8 meters. That is the actual dimension of the face of the Ratha, one face of the Ratha, 8 meters wide. So as we have seen in the inverse drawing before, 1 in 100 means that the drawing is reduced 100 times. This means that the drawing is 1/100th of the size of the actual. So the one face that is 8 meters long is reduced 100 times. Now 8 meters is 800 centimeters. So to reduce this 100 times gives us 8 centimeters. So one of the faces is drawn 8 centimeters wide and the rest of the building is proportional to that 8 centimeters. So we get a drawing of the Dharmaraj Ratha at 1 in 100 scale. So the scale 1 is to 100 means that 1 unit on paper represents 100 units in reality. 1 centimeter represents 100 centimeters in reality. So therefore 1 centimeter on paper represents 1 meter in reality. So in a 1 to 100 scale drawing, each centimeter shows 1 meter of the actual building. So on the left, the 8 centimeters which have been marked means that it represents 8 meters on the actual building. Now if we make the building twice the size, then each centimeter is now representing half the number of half the distance. So 1 centimeter represents 50 centimeters, or 1 unit on paper represents 50 units in reality. So 2 centimeters on paper represents 1 meter in reality. So in a 50 scale drawing, every 2 centimeters shows 1 meter of the building. So on the left, the 16 centimeters that the marked dimension measures 8 meters on the actual building. One step further, and you can see that in 1 in 25 scale, this building now is 32 centimeters wide. And because the height is way more than the 8 meters, it doesn't even fit in the paper, in the A3 sheet. Whatever is remaining visible is at 1 is to 25 scale. Now, just to go on and offshoot a little bit, this is the idea of scale, that at a certain scale, if we know that the drawing is at a certain scale, then we know the size of it. But suppose we don't have, or we're not given the scale. As architects, we must get very good at drawing the standard scales so that we understand the proportions of what we are looking at or what we want to design. We understand the sizes of things best in relation to the objects we know best. And one of the objects we know really well is our own body. Usually, when we walk around in the world, we understand the sizes of things primarily and unconsciously in relation to the sizes of our own bodies. And human bodies are generally the same and fall within a small range of sizes. And this is how we recognize the actual sizes of things. Without a human reference, however, it's nearly impossible to say what size something is. If we look at this pavilion above, what are its dimensions, can we say? Is it possible to say from this image? Now, one can very easily say it. We can roughly say what size it is because we can see an adult human with a child. But if the human is drawn like this, then the size of the building changes in relation because the humans are smaller, and we've already understood that humans are roughly a standard size. If we draw it like this, then the building is way, way, way bigger than we first saw it. And if we see it like this, it's just a stool, it's not even a building. So depending on how we show the relative sizes of other things, especially humans, we see the sizes of things. But if we have scale in a drawing, then there is no need for a human reference, or it is not absolutely necessary. So if you see a drawing like this, you can see the scale is written down on the top, in the bottom left. It says 1 in 20. So the moment we know that every unit on this paper represents 20 units on site or in reality, now it is very easy to find out what are the sizes of all the members, all the doors, all the windows, all the parts of the roof, all the steps, and how we have to order them, get them made, and send it to site for construction. So if the scale is mentioned, then it is very easy to know what the sizes of things are. This is why the notation of scale is in the drawing is so important. Now, this requires some practice. Even though you might have understood the concept, it so happens that when we have to make drawings at several different scales, it can get confusing. It takes a little while to get used to this, and we'll do some practice. So now in this A3 sheet, there is a gray box in the left side of the sheet, and that gray box is 1 centimeter tall. So that 1 centimeter represents 2 meters or 200 centimeters in 1:200 scale. And there is a human being in there. We've already seen who it is, who is within this box. It appears as if the human being is spanning the entire height, but it's not. It's his hands, I believe, if we zoom into the image. And so at 1:200 scale, the gray box is 2 meters tall, and the human being fits very well within. Now, the color box behind the human figure is 2 centimeters high, and at 1:100 scale, it represents a real height of 2 meters, because each centimeter in 100 scale represents 100 centimeters in reality, so 2 centimeters represents 2 meters in reality. Now, another scale jump. The color box now is 4 centimeters high, showing a real height of 2 meters. So the height is remaining the same, but the scale is changing. So 4 centimeters, each centimeter representing 50 centimeters, equals, the whole height of it equals 2 meters. And Dhanush is now fitting well within as he was before. 1:25 scale, the color box is 8 centimeters high, again representing 2 meters, and another jump in scale. In 1:10, the box is 20 centimeters high and showing still a real height of 2 meters. 1:5, now the box is 40 centimeters high and it goes outside the sheet. But again, the real height is still 2 meters, and Dhanush is Dhanush. And now this is 1:1. So the face is almost fitting exactly at his real size within the sheet. So this is another way of showing the notation or giving a scale to a drawing where it is not fitting into the standard scales. It's called graphical scale. If we have a fixed size of sheet, say for a book publication, then given the size of the building, it may not fit within the book. 100 may not fit, or 1:50 may not fit. In such a case, we show the drawing with a scale that is graphical. You can see the graphical scale is at the bottom left of this building. This is Brideshwara Periya Kovil in Tanjore. And you can see that on the bottom left there are two scales. One is showing meters, the above one, and one is showing feet. And from this you can very easily say what is the size of anything in this building or in this plan when comparing it to the scale below. So you can tell it in meters, or you can also tell it in feet. And this drawing is not, the size of it on paper is not to any particular scale, but you can still tell what is the size of something given this graphical scale below. This is very, very important. Also important is that if the plan changes size, the graphical scale also changes size to the exact factor of reduction or enlargement, because it is still representing the same number of meters as the plan is. So if the plan reduces, the scale size also reduces. Now in this drawing, for example, within the same sheet, there are drawings of several scales. And what happens then is that the graphical scale shown to represent the entire section of the building above is different from the graphical scale shown to represent part detail of the roof. So each one will require its own graphical scale. So there are several standard scales, and most of these ratios are called metric scales when it is 1:1, 5, 20, 25, 100, and so on. I'd said that we'd talk about this particular name, the metric scale, but maybe we'll do it in the next class. But these are the metric scales that we're talking about. So the standard ones, so for example, this is 1:20. In 1:20, there is a detail of the wall of a building cut in section, showing all the details of how the floors are, how the basement wall is, and so on. And on the right, there is a facade and how the facade is actually made with the windows and so on. In this, even if it's not necessary, they've shown a human figure. So it also gives us a general sense of what is the size, even if the scale is there. So this is quite useful. Even without looking at anything, quickly looking at the drawing, if you see a human being, you know what size it is. So this is 1 in 20. On the bottom right of the building, there is a 1:1000 drawing. So that 1:1000 is a key plan. It's really small. It shows the entire building. And the key plan is there just to show where in this building this facade is located. We've seen this before. This is 1:100. This is also 1:100. So different scales reveal different things about the building. In this, for example, you can see the entire building, all the rooms, all the parts, and so on. But it doesn't show very detailed things. It's not possible because this scale in each centimeter represents 1 meter, so it's very tiny. Same with this, you can see the overall section of the building, but not any more detail than that. Then you have 1:400, which is even smaller. But if the building gets smaller, then you see much more site around, much more context around. So 1:400 makes the drawing of the building itself smaller, but you can see larger parts of site. And this is 1:1000. It's written 100, but this is 1000. So these are all the standard sizes of drawings, and each type of drawing, if it's a site plan, if it's a section, if it's a detail of a door or a window or of a particular part of a flooring and so on, there are different scales which are better or worse to use to draw these up so that they are best understood on site. This is not something that you need to worry about right now. Just the concept of scale is important. But you have this thing written out on your triangular scale. So suppose this is 1:100. And I've marked out 1.7 meters on 1:100, and my human being is directly available at 100 scale from that 1.5 centimeters on the scale. Now in 50, that will be double. So that's 1.7 into 2, 3.5 centimeters. This is the human being, roughly 1.7 meter high human being at 1:50 scale. And then this is a standard room with 3 meter height and so on. And we have these scales at hand. You know quickly, just flip your ruler around and draw it at the scale that is necessary. So every time you have to draw at a particular scale, you don't have to think of all this. You just have to pick the right one and use it. But in time, you will realize how foundational this concept is to architecture that has to be understood, drawn, and designed on paper. Scale is a very critical tool that relates the paper reality to outer reality.